Assalamu alaikum. So today we'll solve questions from chapter 1, and this question covers the topic of dimensional analysis. So the question reads, consider the following equation: x equal at squared plus b divided by v plus alpha multiplied by t, where x is the distance, t is the time, v is the speed, then find the dimensions of b. So to solve this question, we start with the main principle of dimensional analysis, that I have three quantities. These quantities are the basic quantities. So the first quantity is length, and this square bracket indicate that I'm asking for the dimensions of length, which is L. And the second quantity is time, and this square bracket indicates also the dimensions of time, and similarly for mass, and indicates the dimensions of mass is m. Then if I go back to my equation, x equal a t squared plus b divided by v plus alpha t, then because the question said that x is a distance, so each term of this equation by itself is a distance and has the dimensions of length. So then to find b, I can say that dimension of x should equal L, and the dimensions of the whole term at squared should equal L, and also the dimensions of the whole term b, v plus alpha by t should equal also L. So the unknown is b, but there is another information in the question given, which is that v is the speed, and we know the dimensions of v should equal L divided by t, length divided by time. And because it's added to another unknown parameter, which is alpha, but because I can conclude that because v is the dimensions of v is length over time, then alpha has also to have the dimensions, because I cannot add two terms without knowing that they have the same dimensions. So all this term here should be given in length per time. So the dimensions of b and the dimensions of t is t divided by the dimensions of speed, which is length over time. All this should equal the dimensions of length, which is L. So if I now multiply this side by this side and divide by this side, I can conclude b, the unknown. So the dimensions of b should equal L divided by t multiplied by L divided by t, which is L squared divided by t squared. Or this answer can also be given as the dimensions of b equals L squared t minus 2 by raising this term here to the numerator. Now we can add something to this equation, or to this question, sorry, by also, what if we want also to find a, the dimensions of a? So it's now simple. We can follow the same rule. We can say that the dimensions of a t squared as a whole, the whole term here, should be given in length L. So this will give that the dimensions of a should be t squared should equal L, because the dimensions of t squared is big T squared. So this will give me that the dimensions of A should equal L divided by t squared, or in some books written as LT minus 2. And this concludes the answer. Thank you. Assalamu alaikum. Today we'll solve questions from chapter 1 on dimensional analysis. So this question reads, the speed-time relation of a moving particle is given by v equals half at plus b divided by t plus c, where v is the speed, t is the time, and a, b, c are constants, find the dimensions of a, b, c. So again, we have the main principle of dimensional analysis. We have three quantities. These quantities are time, length, and mass, and they have the three basic dimensions. So the first quantity, the dimensions of length is L, and the dimension of mass is M, and the dimension of time is T. Then if we go back to our question or equation, V equals half A T plus B divided by T plus C. Then from the equation, we should know that the dimensions of each term, which means this term, and this term, because it's a speed, given this information in the question, so the dimensions of this should be length divided by time, and the dimensions of this term is also length divided by time, and the dimensions of this term should be length divided by time. So in order to solve it, what if I start from the last term and I take that B, dimensions of B divided by T plus C should equal speed and has the dimensions of length divided by time. And because this is known to be time as given in the question, so to be added to this constant also has to have the dimensions of time. So immediately I can conclude that the dimensions of C should equal T. And now the same equation can be given as the dimensions of B divided by what we found here, the dimensions of C to be T, should equal L divided by T, which will give that the dimensions of B will be, I can cross this with this, will be L. Now the last term I need to find, which is, or the last constant, is A. So the dimensions of half A T also by itself should be given as L divided by time. And half is a number that is dimensionless. And A is the unknown. So this will give that the dimensions of A by the dimensions of T, which is time, should equal length divided by time. So this will give that the dimensions of A, I just rearrange this equation, will be L divided by T squared. This is the answer. Thank you. Assalamu alaikum. So today we'll solve problems from chapter 1 on dimensional analysis. This problem reads, what is the dimension of the constant G in the equation F equal G m1 m2 over r square, where F is a force, m1 m2 are masses, r is the distance between the two masses. Now this is a law of universal gravitation law by Isaac Newton. And to start with, we can take the main equation given in the question, F equal G m1 m2 over r square. And we're supposed to find the G constant dimensions. So I can put G in one side and all the other parameters in the other side. So I can put G, so I multiply r square by F. Then I divide by m1, m2. This way I put G on one side and everything else on the other side because I'm targeting to find the dimensions of G. Now, I know that the dimension of G, basically, I should find the dimensions of all its components, r square, F, and the dimensions of m1 and the dimensions of m2. So r square, the dimensions of r square are L square, because we know that r, length or distance, dimension is L, and mass, dimension is big M, and time, dimension is big T. Those are the three basic dimensions. So, however, I don't have a direct dimension of F. So if I go back to Newton's second law, where it said F equals ma, this is the Newton's second law, then I can tell that the dimensions of F are basically made of dimensions of m and dimensions of acceleration, which means the dimensions of m is big M, and dimension of acceleration is length per time square. So it should be length per time square. Now I can substitute this dimension into my equation. So L square, I will substitute this instead of here. So it will be m L over T square. The last thing left is to substitute for the dimension of the masses, which is for the dimension of this mass, m, and this one is another big M. Now I can cancel out 1m, so the dimensions of G will be L cube, because this is power 1, so L cube divided by L cube divided by T square divided by m. Or it can also be written as L cube T minus 2 m minus 1. And this concludes the answer. Thank you. Assalamu alaikum. Today we solve problems from chapter 1 on dimensional analysis. The question reads, suppose the speed of a wave on a string is given by v equals k tau to power m mu to power n, where k is a dimensionless constant, tau is a tension in the string, and mu is the mass per unit length of the string. Find the values of n and m. So m and m here are two unknowns. We need to find their values, their power values. So I can start by saying that this equation, I will take my equation, v equals k tau to power m mu to power n. Then if I can utilize the dimensional analysis principle, which is that the dimensions of this side should equal the dimensions of this side, then the dimensions of v has to equal the dimensions of all the parameters in the right side of the equation, tau and mu. I know the dimensions of v because it's a speed, so it is length per unit time. And it's given here in the question that k is a dimensionless constant, so we replace it by 1. So just 1 we replace it. And tau, it's given in the question that it is the tension in the string. Now tension, as you will see in chapters 5 and 6, is one type of force. So because tension is a force, so I can utilize the dimension of the force. F equals ma, then the dimension of F should equal the dimensions of m and a, which is m length per time square. Okay? So then we substitute this result for the tau, because it's type of a force, into here we substitute it here, so it is m L over T square, all raised to power m, because all the tension is raised to the power m. And the mu is given as the length is the mass per unit length, which means mu is mass per unit length, so it has the dimensions of the mass and the dimensions of the length, so it is m divided by L. Now I can substitute also this result and raise it to power n, so I can say that this will be m divided by L and raised to power n. Now, my roadmap here is to relate the powers of this side with the powers of this side. So I will associate these parameters together. So this side is L divided by T, and this M is raised to power M, this M is raised to power N. So I can add the two powers, so M equals N plus M. And L is raised to power M, while L here is raised to power minus N, because I can raise it here. So it is L, M minus N. And then T square, basically here, is raised to power T equal to M. Now, I can compare the left side with the right side. On the left side, I don't have a dimension of the mass, which means that if I have an M here, it will be the power 0. So that's why it doesn't appear, it's 1. So I will say that I can extract three equations, N plus M, because it equals here 0, the power of M here on this side is 0, should equal 0. This is the first extract. The second extract is that M minus N should equal here the power 1. This is equivalent to L here, should equal the L here. So this should equal 1. And I can also compare the time dimension here with the time dimension here. So this also the power 1. So also 2M should equal 1. If you recall the question again, we need to find the values of M and N. So the first answer, easy answer, will be to get M. So M, I can divide 1 by 2. So M equals positive half. And then I can substitute this M into this equation, and then I can get N. So M minus N equal 1. So M is a half, minus N should equal 1. And this will gives me that N, take N to this side and take 1 to this side will be minus 1. So minus 1 plus half, so it should be minus half. So now I found, to summarize, I found that M equals plus half, and I found that N equals minus half. And we can here, before we finish the question, we can recheck our results by applying those values to the first equation, for example. If it's true, the values that I obtained, then N plus M should equal 0. So N is minus half, M is a plus half, which equals 0. Thank you. Assalamu alaikum. Today we'll solve problems from chapter 1. This problem is on the unit conversion. It reads, find the mass of a solid cylinder of copper with a radius of 5 centimeters and height of 10 inches. If the density of copper is 8.9 gram per centimeter cube, and he gives you a hint that 1 inch equals 2.54 centimeter. So my target, I have a simple sketch will help me to understand the problems all the time. So I have a cylinder. This cylinder has a radius and has a height. This height is 10 inches and the radius equals 5 centimeters. And this is actually a solid cylinder, which means it's filled with the material of given here, which is copper. And also another information given to me that the density of copper equals 8.9 gram per centimeter cube. This is given in the question. And now he is asking for the mass of this solid cylinder. I know the relation between density, mass, and volume. So if I know the density and I need to know the mass, all I need to do is to find the volume of my cylinder. So the density equals mass over volume, which gives that the mass should equal density multiplied by volume of the cylinder. And this is, of course, the density of the material of the cylinder, which is copper. So now, I need to find the volume of a cylinder. to find the volume of a cylinder, it's like the volume of any quantity. It is the area of the base multiplied by the height. And the area of the base is basically a circle, and the area of a circle is pi r squared. So the volume of a cylinder will be area of base multiplied by height, which means area of the base is pi r squared multiplied by height h. Now I have a small issue to tackle, which is the units are not consistent. So means that this is pi, it's a constant, 3.14. R square is 5 centimeter square, but h is given in inches. But he gives me here also a hint that 1 inch equal 2.54 centimeter. So I need to convert this 10 inches into centimeters. So I can convert it by saying that 10 inches using the unit conversion is basically 1 inch equals 2.54 centimeter. Notice here that I multiply by 1, because 1 inch equal 2.54 centimeter. This is the principle of unit conversion. So basically I'm multiplying by 1. So I'm not changing anything in the equation. So I can cross this inch with this inch. So the volume of the cylinder now will be the multiplication of pi 25 and 10 by 2.54 means 25.4. And of course, this is centimeter, this is centimeter square, this is centimeter. So it has to be given as 91995 centimeter cube. Now, it's okay to get the volume in centimeter cube as long as I don't mix it with other quantity. I did not try to substitute for inches here directly because it will give me a wrong answer. So now I got the volume of this cylinder in centimeter cube. Now the mass of this cylinder, as the question asks, equals rho by V, which means 8.90 gram per centimeter cube. This is the density of copper, multiplied by the volume of the cylinder that I just found, which is 1995 centimeter cube. And if I multiply these two quantities, I will get 17,780 grams. Notice here to check that centimeter cube will be crossed with centimeter cube. So the answer has to be in mass. It's a gram. So this 17,780 grams is the mass of this cylinder. Also, I can convert it to modify the equation or the question. I can convert it into kilograms. So the mass in a gram is 17,780. So the mass in kilogram will be the mass in a gram. And now I need to look for the conversion factor between a gram and kilogram. I know that 1 kilogram equals 1,000 grams. So I need to substitute the grams here. So 1 kilogram equals 1,000 grams. Now I can cross the gram with the gram. So I'm left with a kilogram, which is 17.78 kilograms. This is the mass of the cylinder, and this concludes the answer. Thank you. Assalamu alaikum. Today we're solving problems from chapter 1. This simple problem reads, a 0.19 kilogram solid sphere has a radius of 21 millimeters. Its density is, so we need to find the density of this solid sphere. So remember, this solid sphere basically is a sphere filled with material. So I need to find the density of this material. So basically what I have the mass of the sphere, which is 0.19 kilogram, and I have the radius of the sphere, which is 21 millimeter. So if I need to find the density, density should equal mass divided by volume. The mass here is given already in kilograms, but the volume I need to find, but the dimensions for the volume are given in millimeters. Remember, I cannot mix kilograms with meters. I can also only use kilograms with meters or centimeter with grams. So basically, I need to convert this radius and then the volume into meter cubes. So the radius of the sphere in meter will be the 21 millimeter, and then I need to multiply by the conversion factor between meters and millimeters, which is 1 meter should equal 1,000 millimeter. So this millimeter will cancel with this, and then I'm left with the R of the sphere in meters should equal 0.021 meter, because I divide 21 by 1,000. Now, I can use this result to find the volume. So the volume of this sphere is 4/3 by R cube. I can substitute all the results here. Density equals 0.19 kilogram divided by 4/3 by, and this multiplied by R cube, which is 0.021 raised to power 3, and this basically should be given in meter cube. This is volume. So if I use my calculator and I divide this by this, then I'll get the density of this solid sphere as 4.9 10 to power 3 kilograms per meter cube. Notice here that the unit of density is logical. It's mass divided by volume. Thank you very much. Assalamu alaikum. Today we're solving problems from chapter 1 on unit conversion. The question reads, express the speed of sound, 330 meters per second. This is the speed of sound in air, in miles per hour. So instead of meter per second, I need to find it in miles per hour. There is a unit factor given here, is that take 1 mile equal 609 meters. So I start with the speed of sound in air as 330 meters per second, and I need to convert this speed into miles per hour. So I can start step by step, and I can say that 330 meters per second, to go to miles, all the way to miles per hour, I need to convert the time into hours, and I need to convert the distance into miles. The conversion of distance is very simple, which is, this is the unit conversion, 1 mile equals 1609 meters. Notice that in unit conversion, I multiply by 1, because if 1 mile equals 609 meter, then if I divide this side by this side, or this side by this side, basically, because they're equal, I'm having 1. So 1 mile by 609 meter basically is 1, and 1609 meter divided by 1 mile also is 1. So if I to multiply by 1, I'm not changing anything. This is the essence of unit conversion. So I go back to my question. The meter will be crossed with the meter. So then basically now I did convert the distance into, instead of meter, into miles. Now I need to convert the time from second to hours. And I do it step by step. I know that 1 minute equals 60 seconds. So now I can cross the seconds with the seconds. Remember, I need to reach 2 hours. Then I know that 1 hour is basically 60 minutes. So now I can cross 60 minutes with this. Then if I multiply 330 by 60 and divide it by 1609, the answer will be 738 and miles per hour. To check, I have here 1 mile, and in the denominator, I have it is hour. So it is 738 miles per hour. Thank you very much. Assalamu alaikum. Today we're solving questions from chapter 1. The question reads, a hectare is a unit area that is equal 10 to the power 4 meters square if water of volume 0.02 kilometers cube covers 30 hectares of a flat land. Find the depth of the water. So basically I have the volume of this water and I have the area of this water, and I need to find the depth. So the volume equals area multiplied by depth. This is the definition of the volume. So the depth will be volume divided by area. But the volume is given to me in kilometers cube, which I need to convert to meters cube. And the area also is given in hectares, which I need to convert to meters square. So in order to convert them, to get the answer depth in meter, I know that 1 kilometers is basically 10 to the power 3 meters. So 1 kilometers cube is 10 to the power 3 cube meters cube. And 30 hectares, I need to convert it. So 1 hectare equals 10 to the power 4 meters square. Now, or on the other side, I have to make a correction here, or 1 hectare equals 10 to the power 4 meters square. So now I can cross hectares with hectares, and I can cross also the kilometers cube with kilometers cube, and I am now dividing meters cube by meter square. So the answer will be, if you do the calculation on a calculator, 67 meters. So this is basically the depth of the water. Thank you.